Greetings and welcome, friends. We've been talking about, I think, like polygons and distance formula. I don't remember stuff. But either way, here's some homework. You clicked on this video. I don't know what you're doing. You know what you're doing. I hope you clicked on the right thing. It's your fault, not mine. Classify the polygon by the number of sides and tell whether it is convex or concave. So number of sides here is 5, more typically referred to as a pentagon. Back in the day, I actually came up with an idea. I see, what was it called? I think I called them Polygon, and they were two-dimensional creatures, and one of them was named a pentachu. He was a 5-sided Polygon, and he would always say penta, penta, and like, oh man, the sum of his interior angles, you could like remember all of the stats about them. Like his interior angles, I think were like 540 degrees. Pretty good. I actually animated a PowerPoint, a battle between him, Pentachu that is, and a Trapezoid. That was pretty amazing. He was like a trapezoid. He's a quadrilateral type Polygon. Seriously, I could have made millions of dollars, but I didn't. Such is life. But anyway, so here's a regular pentagon, not a pentachu, not to be confused. Similar, not the same. Now this has no dents in it, so this is convex. One of the ways I like to describe it, let's see, what's a good, looks like this color right here. If you imagine taking a rubber band and wrapping it around the figure, that the rubber band would be touching all of the sides. Whereas, for instance, this one, if I put a rubber band around it, it would have had this gap, this space right here, because that one's going to be concave. Yeah, this one looks like n is equal to, oh, I got to go back to my more vibrant colors there. 1, 2, 3, 4, 5, 6. And so that's a hexagon. And it is concave. It's caved in. It's dented. The way I remember that phrase. Eventually, we'll talk about concepts such as what do you call a polygon when all of its sides are congruent to each other? Does anyone know what that's called? Equilateral. And today we're going to be talking about angles, but if all of my angles are congruent, that's equiangular. And if it's both of those things, it's called... No? Wait, what was your... Oh, sorry, you did. Yeah. Maybe I just didn't hear it correctly. Yeah. I don't know. Yes, regular. Regular would be if, yeah, it has both of those features. So yeah, so there you go. Anyways, yeah, let's keep cruising. So here's question 11. For sake of time, I kind of stole the work from the book for 2 of these distances. You would use the distance formula for any diagonal segment from point to point. But for horizontal ones, such as this one, MN, you could just use, either count those boxes, or use kind of a one-dimensional distance formula, where you could subtract and then absolute value that difference between just that single coordinate, the ones that were different. So 4 minus 2, yeah, that's a distance of 2 there. So let's see. So what do I got so far? PL was the 0.32. LM right there was 5. Huh. It's actually a special one right there. Why that's special? What I just outlined? Yeah, this is a 3, 4, 5 right triangle. So that's called a Pythagorean Triple. Don't worry, we'll learn about those later too. So that's one maybe you could have glanced at and been like, aha, 3 and 4, that one's going to be 5 with 0 calculations. But no, you had to calculate. And then for this one, looks like NP. I'll do the distance formula proper there, because I already cheated. So let's see, x2 minus x1 all squared plus y2 minus y1 all squared. Double close those parentheses. 2 minus negative 1 is the same as 2 plus 1, so that's 3 squared. 0 minus negative 2, that's 2 squared. Like the square root of 9 plus 4. root of 13. That roughly. Yeah, my other window open. Ooh, 3.61 roughly. Which, by the way, this symbol, anyone know what that one means? About, yeah, approximately. It's I call it a squeakquel sign. It's like a squiggly equal sign. He's like not too sure of himself. He's like 3.61 maybe, and so like he's a little nervous about his answer, but it's gonna work. And then yeah, if I add up 6.32, 3.615, and 2, I'm getting the answer here as 16.93 units is the perimeter of the entire figure. Okay, so that kind of repeated distance formula stuff going on there. That's a little bit of work. Okay, so for this one, to calculate the area of this polygon, question 15, I already plotted the points. To find the area, this looks like a square. What's the area of a square formula? S squared, or if I view this as a rectangle, what's the area of a rectangle? Base times height. You guys are good. And these ones are horizontally read. You can see that's 3, that's 3. So the area is just going to equal 3 squared, which is 9 units squared right there. Another way you could have done that is because the grids were 1 by 1. All right, if that was a different number, you can't just look at this and count the boxes. But notice that there's 9 square units that fit inside that space. You can count it only if the grid is 1 by 1. Now, if it was a different measurement, you could still count it, but then you usually have to multiply it by the square of that dimension. So if those were 2 by 2 boxes, I'd have to multiply by 2 squared, whatever my number of boxes was, in order. Don't worry about that right now. You're fine. Okay, let's see. Look at how fast Mr. Waddy cheated on this one. So it looks like I've got the dimensions, linear dimensions, figured out. Some of these are diagonal. Actually, all of them are. So you had to figure that out. But you maybe could have just looked at some congruence. Let's see, what's a color I can use? Man, they've got colors. You might have realized that this segment was congruent to this segment was congruent to this segment. Right? Maybe you could have shortcutted that a little bit. Done some distance formula. What were your thoughts? Yeah. Mm-hmm. Aha, I like it. So that's another shortcut that I will allow that I have not shown you folks yet, is that a square that is 1 by 1 has a diagonal that sometimes people think is going to be 1, but that is not the case. Because the shortest distance between 2 points, here's one explanation, is a straight line. And so this distance must be shorter than the distance of going around, which would be 1 plus 1. So it's somewhere, it's longer than 1, if I was to kind of arc that distance, but it's less than 2. And one of the ways you can do that is using Pythagorean Theorem. That's not right. And you end up with 1 squared plus 1 squared equals squared. You end up with 1 plus 1 equals, C ends up equaling 2. You're correct. So if I was counting this, the number of direct diagonals, like corner to corner, right, on those boxes, this is 1, 2, 3. So I would have expected that this distance was 3 square roots of 2, which I should find calculator-wise is going to be approximately. I can't use that technique on this one because that's not corner pinning those boxes perfectly. So I would use regular distance or Pythagorean Theorem for a 1, 5 leg lengthed triangle. So here we go. If I want to find the area of this thing, perimeter, you would have been adding up all of those outer dimensions, depending on what they were having you find the perimeter of. Let's find the perimeter area, of the triangle, green triangle. So that's going to be half the base, which doesn't matter which base I call it. Actually, did you guys realize that was a right triangle? Do you feel as though you could justify that you knew that that was a right triangle yet? Ooh, actually, you can. Back in your Algebra 1 days, you had a way to determine if lines were perpendicular in the coordinate plane. Does anyone remember how? What? Yes. Okay, yeah, you ended that sentence the way I would have begun it. But yes, you're correct. The slopes are opposite reciprocals of each other. Remember that trick? Wow. Good old days. So yeah, so this segment has a slope of up 1 over 1, or a slope of 1, and this segment has a slope of down 1 over 1. Those are opposite reciprocals of each other. Therefore, these lines are perpendicular, and perpendicular lines have a measure of 90 degrees. It's a right triangle, friends. It's a right triangle. Also, that's true over here. Here's a slope of 1. Here's a slope of -1. Those aren't the most interesting slopes for opposite reciprocals, but reciprocating 1 is 1. So anyways, so either of these could have been the base. It doesn't matter. So half of 4.24 times 2.83. And I guess these were technically approximations all the time because I've already rounded. And passing rounded numbers through a formula is going to actually further round them. I believe you get about 6 there. Is that right? That's what my notes here say. And then let's see, area of the rectangle, that's just going to be base times height, 5.66 times 2.83. You guys are all experts at this, right? I ended up getting about 16. And then for the blue triangle, actually, would my box counting technique work here? Check out this. 1, 2, 2.5, 3, 3.5, 4. Just to point out that, like, you could combine the true half boxes with other true half boxes and end up getting that. When you add those all together, you get the area of the... Oh, it was a trapezoid. Notice. Trapezoid the whole time. 6 plus 4 plus 16 is 26 units squared. Something like so. Right? See, was that the last-ish problem? I think so, right? Yeah. All right. Well, thanks for watching, Internet friends. Bye.